All right, for the function f of x, we're going to sketch the function by finding the oblique asymptote, or the slant asymptote, and the vertical asymptote, and the x and y intercepts. All right, so for the slant asymptote, so we'll say SA, we're going to divide these. So we'll write this as, well, what I'm going to do is I'm going to write this in a better, or no, not square root. We're going to write this as, with our descending power of x, so negative x squared plus x plus 1. All right, and then we're going to divide that by x. So from there, this one's a little easier than the last one, right? Because now we're just saying, okay, how many times does x go into negative x squared? Another way of saying that is, what is negative x squared divided by x? So that would be negative x. Negative x times x is negative x squared. And then, unlike the last one, I'm not going to have, like, multiple terms here, right? I just need to actually subtract this now. So we're just going to subtract this. So negative x squared minus negative x squared, that's like adding. That becomes 0. And then I'm going to bring down the x. So then we have plus x. So then how many times does x go into x? Well, it goes in 1 time. So plus 1. 1 times x is x. But then we're going to subtract it. So we get 0. We're going to bring down the 1. All right, so then plus 1. So now, how many times does x go into 1? Well, it doesn't, so we're kind of stuck. You could say plus 0 there, but that's where we're at now. So 1 really is going to be like a remainder we can think of in this case. But the slant asymptote is the quotient of our division, right? Okay, so let's just formally state that now. We'll say the slant asymptote is at y is equal to negative x plus 1. And I said y is equal to negative x plus 1 because it really is a line, right? So our line is going to be, something like that. Okay, so there we go. So we have that one. I'll add that to the actual graph here in a minute. But let's now find the vertical asymptote. So our vertical asymptote, or VA, is going to be, well, that's going to happen when the denominator is equal to 0, right? When you're like dividing by 0 there. So that's going to be, that's easy. That's going to be when x is equal to 0. So that's going to be our vertical asymptote. And you know what? Just to start to get a feel for this, let's draw those in. So I'll put my vertical asymptote in there at x is equal to 0. So that's right along the y-axis. Okay, so there's 1. All right, and then let's sketch our line too for our slant asymptote. So negative x plus 1, so that has a slope of negative 1, and it crosses the y-axis at 1. So that's going to be, you know what? Let's do this. All right, that was pretty impressive, right? Okay. All right, so there's my vertical asymptote, my slant asymptote. Let's now see what's happening at these, like, along these points. And it'll be nice if we just figure out what's happening around this vertical asymptote. That'll actually tell a big story about what's happening with the slant asymptote as well. So let's do that. Let's find the limit. Let's find the limit as x approaches 0 from the left. 1 plus x minus x squared over x. Okay, so now think about what happens when you put in a very, very small negative number. So just to help you out, that might be something like negative 0.1 or something, right? Like, that's a small number. Now I'm putting that in for x. So what's happening here, I'm going to add some very, very small number close to 0. And then I'm going to subtract, a positive one too, because it's going to be squared. But either way, it's pretty much adding 0 or subtracting 0. this 1's coming out, right? That's all that's going to happen there. So the numerator is going to come out positive. Okay, because this is pretty much 0 and that's pretty much 0. Okay, now the denominator though, so the denominator in this case is going to be approaching 0, but it's going to be negative. So I've got a negative number in the bottom. So this thing is going to come out as, positive over negative. This is approaching negative infinity. Okay, so then actually while we're on that, so what we just did, that means that we're going to be approaching negative infinity down this way. And if we like, I can kind of tell where this is going, right? We're going to have to be approaching it up here, but I'll get there in a minute. All right. So then the limit as x approaches 0 from the right. So same type of thing, our numerator. So if we have 1 plus x minus x squared over x. So our numerator here, it's going to be like these x's are going to become 0. So it's all about the 1, which is positive. So the numerator here is going to be positive. And the denominator is going to be positive. So this is coming out as approaching positive infinity. All right, so then in this case, we're going to be approaching positive infinity, so up this way. All right, so now the question didn't actually ask us to find any horizontal asymptotes. And the reason why it didn't is because you can see our numerator is a higher degree than the denominator. So I know that this is going to be the case where, we don't actually have a horizontal asymptote. All right, so now let's find the x and y intercepts. So that'll be the next piece here. So let's find the x-intercepts. Okay, so the x-intercepts are going to happen when y is equal to 0. So we'll say 0 is equal to, and then our function is 1 plus x minus x squared all over x. But again, like I've done in the past videos, I don't actually care about the denominator at all. I'm just going to focus in on the numerator, finding these, because that's the one that's going to make it equal to 0, right? So, all right, so let's try to factor this. Turns out it actually doesn't factor. So here, if I have negative x squared plus x and then plus 1. So if it doesn't factor, then what we're left with is the quadratic equation. So I'm going to call this my A, my B, and my C, right? And then we're going to plug this into the quadratic equation. So negative b plus or minus the square root of b squared minus 4ac all over 2a, and then we'll fill it in. So this becomes negative, so my b value is really 1, so negative 1 plus or minus the square root of 1 squared minus 4 times my a value is negative 1, and then my c, a lot of ones, my c is 1. All over, and then 2 times negative 1. So simplifying this a little bit more, we get negative 1 plus or minus the square root of 1 squared is 1. Now I can see that I've got negative 4 times negative 1. This is going to come out as plus. Negative times negative is positive, so plus 4. So square root of 5 over negative 2. Let's carry on up here. So now we have x is equal to negative 1 plus or minus the square root of 5 all over negative 2. All right, so these are my answers. If I want to sketch this thing, though, it's a little bit awkward with the square roots. Let's actually just plug it in. So we can, if we plug that in, we end up getting x, two answers. X is equal to negative 0.61. And x is equal to 1.61. So we can plot those now. So 1.61, right about there somewhere. And then negative 0.61 be around there somewhere. All right, and then we're almost there. Let's find the y-intercept. So the y-intercept happens when x is equal to 0. So if we plug that into our original, you'd say y is equal to 1 plus 0 minus 0 squared all over 0. This doesn't exist, so does not exist, which actually makes sense because I had a horizontal asymptote at x is equal to 0, so it never was going to cross there anyway, right? All right, so I think we have enough. So let's use that. So I know I'm approaching infinity on the right side of that asymptote. It comes down. Oop. Try to be a bit more smooth than me on my computer. Ah, come on. It passes through my x-intercept. And then I got off there, but I think you get the idea, right? It approaches that asymptote there. And then the same thing happening in this direction. So something like that.